Let's practice verifying a trigonometric identity together. Now, looking at the two sides of this equation, I think the left side is a little bit more complicated, so let's go ahead and mess with that side and make it look like the right side. So basically, we're going to take this left side and apply some of our trig identities to it, and make sure we can simplify it so it looks like this right side of 2 times cosecant of theta. Alright, to begin now, I'm just going to start by writing the original expression on the left side. So we have sine of theta on top of 1 minus cosine of theta. And we're going to go ahead and add on this 1 minus cosine of theta over this sine of theta. Now, if you look at the right side of the equation, we just have one term. It's just 2 times cosecant of theta, but right now we have two terms. So I think what I'm going to do is I'm going to see if we can get common denominators here so we can add these two fractions and just have one fraction instead. So let's go ahead and take this original expression, and let's just go ahead and rewrite it or copy it over here where I have a little bit more space. And to get common denominators, this denominator over here is missing the sine of theta that the other fraction has down there, and this fraction over here is missing that 1 minus cosine of theta that the other fraction has in its denominator. So I'm just going to go ahead and throw in some parentheses, put a hug around everything just to keep things organized. I know some of them don't need them, but I just like putting them in just in case. Makes me feel a little bit better about what I'm doing. Keep things nice and organized. So on the left side here, let's go ahead and multiply this one. This one needs a sine on the bottom, so let's take sine of theta and multiply it on the bottom as well as the top. Again, we're allowed to do this because sine of theta over sine of theta is just equal to 1, so it's using the identity property of multiplication. And then here on the right side, let's do multiply by 1 minus cosine of theta over this 1 minus cosine of theta. So make sure you do that on top and bottom. All right, so multiplying these two fractions. Now, multiplying these two fractions together, on top we have sine of theta times sine of theta, so that's just going to be sine squared of theta, and that's going to be on top of this sine of theta multiplied by 1 minus cosine of theta. Okay, so that's going to be that new fraction right over here, just like that. And then let's go ahead and add this product of the second part here. So I'm going to go ahead and give a hug around this 1 minus cosine of theta, just so everything's nice and organized. Now if we go ahead and multiply these together here, let's go ahead and multiply 1 times 1 and then 1 times this minus cosine of theta. And so this is going to be 1 times 1, which is 1. And then we have 1 times that negative cosine of theta, so it's minus cosine of theta. Then we have negative cosine of theta times 1, and then negative cosine of theta times negative cosine of theta. So we're going to have another minus cosine of theta, and then a plus cosine squared of theta. And while the numerator here was a little bit more complicated, in the denominator we're going to have this sine of theta multiplied by 1 minus cosine of theta, or the same denominator that we had over to the left because we needed common denominators. Now a couple quick things. Let's go ahead and take this minus cosine of theta and minus cosine of theta and combine that to just say that's going to be minus 2 times cosine of theta. So we'll do that in just a moment. And then let's take a look at the denominators. Because we have this common denominator of sine of theta times 1 minus cosine of theta, we can go ahead and add these two fractions together and write one bigger fraction. So we're going to have sine squared of theta plus 1 minus 2 times that cosine of theta. Again, we just combine those, and then plus cosine squared of theta. This entire expression in the numerator can be written on top of this sine of theta multiplied by 1 minus cosine of theta. And just to keep things nice and consistent, I'm going to make this yellow too so we can see that's the common denominator. Now, while I know this looks still pretty messy, believe it or not, we are getting much closer to what we're looking for our answer of this 2 times cosecant of theta. Well, next what you want to do notice is this sine squared of theta and this cosine squared of theta. Again, we're adding these two pieces together because we have that addition over there. So remember what that's equal to. Side note, remember our Pythagorean identity where we have sine squared of theta plus cosine squared of theta is equal to 1. Now I know the sine squared of theta and cosine squared of theta are a little bit far apart from each other, but using the commutative property, you can just kind of rearrange that, and that would just equal 1. So rewriting this, we would have 1 plus the 1 that we already have, minus that 2 times cosine of theta. And this would be on top of this sine of theta multiplied by 1 minus cosine of theta. Next, we can go ahead and add this 1 plus 1 together, and that's going to be 2. So we can go ahead and write that we have 2 minus 2 times cosine of theta, and this is going to be on top of that same denominator that we haven't really done anything with yet. All right, now we are very close. What I'm going to go ahead and do here is let's go ahead and factor out the GCF. If you look at this numerator here, they both have a 2, and this is kind of a little trick that you might not have seen, but hopefully this makes sense. You factor out a 2, that's going to be 1 minus this cosine of theta, and that's going to be on top of what? It's going to be on top of the same thing that we haven't changed. It's sine of theta times a quantity of 1 minus cosine of theta. Okay, now if you take a look here, hopefully you can see that this 1 minus cosine of theta and 1 minus cosine of theta, you can see they show up in both locations. So we can go ahead and cancel these out because they're on top of each other. And then we are left with just 2 over the sine of theta. But again, you could also rewrite this as maybe 2 multiplied by 1 over sine of theta. And 1 over the sine of theta is just equal to cosecant of theta. So we have 2 times cosecant of theta. So there we have 2 times cosecant of theta, and hopefully you can see here that that does match up with what we had on the right side of our equation. So we have proven that this left side does equal this right side. So there you have one way of going about verifying this trigonometric identity that the left side does equal the right side. If you found the video helpful, please consider giving the video a thumbs up and sharing with a classmate or friend who might also find it helpful. As always, keep up the great work that you're already doing, and I'll see you in the next one.